and they freaked and they crushed them. What does that tell you about the sociopathic tendencies of a corporation? What does that tell you when the vice president of corporate and environmental affairs for General Motors Canada is, in my opinion, lying? He is promoting something to you that, I don't know, compared to an electric vehicle, you've got to be kidding. If they wanted to make electric vehicles, they could do it tomorrow morning. I did it in my driveway. You can do it in your driveway. Get a friend, get a buddy, find a mechanic, find an electrician. It took me 4 days to do mine. A month, but it rained 26 out of 30 days. You can do this. I did it. I love driving it. I love what it stands for. It's silent. It produces no CO2. I even get some attention. I kind of like that. So, let's go for a drive and you'll see what it's like to be in. So inside the vehicle is, again, pretty common stuff. So I'll just turn it to the on position. So if you can hear that, what you hear now is the vacuum pump. So that's just pumping up my braking system so that I have brakes. Also the hydraulic pump came on for my power steering. So it still steers pretty much like it used to steer. So I'm in neutral right now. My Zilla, the two indicator lights are currently on. That means it's in an air condition and it won't run. So I'm just going to push in the clutch. Because this is a standard car, the start signal won't come out unless I push in the clutch. So now I just turn it to start. Now I just went tick tick just for a moment. That's all the Zilla hairball requires, is just a quick signal to say, okay, I'm ready to go. The hairball then did a couple of tests and checks that it needs to do to determine that it's in a good condition to work. And if it is, then the solenoid closed, and so now there is power available to me if I ask for it. So, let out the clutch, put it in first gear, or do that in the other order if you prefer. Take off my brake, and here we go. So it's very quiet, there's not much to listen to. You can see that my tachometer works. So we're just going to go down the road and back here so you can see what it's like to drive one of these things. One of the habits that you need to get into when you drive an electric vehicle is to try to let the motor spin a little bit faster than it used to spin. These electric motors are a little more efficient when they run 2,000 to 3,000 RPM. So right now I'm at 3,000 RPM. I would have shifted at probably 1,500 RPM in my gas car. Now, when I stop, I just stop. I don't push in the clutch. I don't do anything. I'm still in first gear. There's no idle, so I don't have to put in the clutch. There's no such thing as stalling. At the moment, I'm kind of on a little bit of a downhill here. Not much of one, just a little gentle one. So just to make the point, I'm going to put it in second gear. Let my foot off the brake, hit the accelerator, and here we go. Just like a gasoline car, it won't accelerate quite as quickly when I do that, but it doesn't stall or anything. And I put it in third gear just like any other vehicle. Now there's one little difference that you kind of have to get used to, which is a gasoline engine, when you take your foot off the gas, the gasoline engine will slow down. It'll slow down very quickly. It'll drop back down to idle speed very quickly. Well, this one won't. In fact, to make the point, I'm just going to I'm going to push in the clutch and let my foot off of the accelerator. If you're watching the tachometer, you can see that it's still spinning at 2,000 RPM, yet I'm not doing anything with the engine. If I let my foot off the clutch, the tachometer didn't move much because the motor was still spinning. So when you change gears in an electric vehicle, you have to remember that the motor, it did not decelerate. So you shift a little bit differently. It's a really easy habit to get into. The hardest reflex to give up was the reflex to put your foot on the clutch when you stop. It took me a while to figure out not to do that it's not necessary. Just go around the corner here, still in first gear. Here we go. Also, as I've mentioned, I've got my Zilla controller turned down, so it won't deliver very much current. I did that in order to maximize the range of the vehicle. I could turn it up again, and if I did, it would accelerate better, but I wouldn't go as far. So it's a trade-off about how you want these things to operate. You just change the setting in the hairball, and you get a new setting. So I currently have mine set, just for you guys out there that might have a Zilla controller, I have mine set to run 400 battery amps and 500 motor amps. I don't understand the difference between battery amps and motor amps, to be honest with you, but there is a difference. Now the default settings would be much higher than that, so this vehicle could go a lot, it could accelerate a lot harder than I let it accelerate. Again, I did that for range, to maximize my range. So this vehicle will do 100 kilometers an hour, or 60 miles an hour if you prefer to think that way. In fact, it would probably go a little bit faster than that. But the harder you draw from the batteries, the more you end up taking out of the battery. So a good analogy would be, the faster you drink the beer, the less beer you get. Good way to think of it. So if you take little sips of beer, or if you pull power from the batteries in smaller amounts, there'll be more power in there for you to take. And that's the big advantage for why I turned my controller down so much, so that I'm taking smaller sips from the battery. What I'm describing is known as the Pukert curve. I think it's P-H-U-K-E-R-T. It was the name of a guy who documented the effect of how hard you draw on a battery compared to how much you get out of the battery. So the Pukert curve affects the range of a vehicle. So that's why I turned mine down. I don't know if other batteries like lithium ion, I honestly don't know if they are subject to the Pukert curve, or if they have a different formula for the Pukert curve. I don't know.